All right, so I'm going to show you guys how to do um, a couple of examples in your calculator for those of you who were not in class the last couple weeks. So I'm going to start off with a binomial example, so binomial distribution. The first thing I'm going to show you how to do is to build a binomial distribution using your calculator. So the first thing you're going to want to do is to actually go into Stat, Edit, and you're going to build a list. If you have something here, you're going to go ahead and clear it out. Make sure you're not deleting the lists, just clear those lists. Okay. Now in L1, I'm going to number it from 0 all the way up to whatever n is. In this case, n is 8. So I'm going to number it from 0 to 8. And so you can just work with me. If you do this correctly, there should be no work that you need to do on your on your own. All right, so we've got our x values. Okay, so remember, x values represent the number of successes. All right, so now what we're going to do is we're going to exit out. So second mode will exit you out. And we want to be able to build our distribution. So I'm going to go to second, vars, and I'm going to scroll down to binomial PDF. And for mine, it's letter A, okay? And we're going to fill in this information. So the number of trials, remember, is n. So my n is 8. My p is the probability of success, so 0.73. To build the distribution, we're going to use whichever value or whichever list we put our x values in, okay? And then I'm going to paste. Then I'm going to go down to store, which is down here left of 1. And I'm going to store that in the next list over. So if I hit second 2, that'll store it in list 2. And then I'm going to hit enter. And now I can go into my list and I can see all of my values. So notice that the solution to the probability of exactly 6 the probability of exactly 6 successes is about 31% chance. Okay, so there's a 31% chance that there's exactly 6 successes going on. Okay, so let's say we get one that's a little bit more complicated. So again, I'm going to leave you guys to practice this. So now it's saying find the probability that the number of successes is at least 5. Okay, so that would be 5, 6, 7, and 8 if we're looking at our list here. So one way that we can do this is we can simply add up these probabilities. So we could say 22.85% plus this, plus this, plus this. And we can add those up by hand, and we will get our solution. We will get the probability that the number of successes are at least 5. Okay, but there is a way to do this on the calculator, and the way you're going to do that is go to second mode that exits you out. Now, this is the new part, so we're going to hit alpha, alpha zoom. Hold on. Give me just a sec. It's second stat. Go over to math, and you're going to go down to sum. Okay, and so the way this works, the way you're going to type this out, it'll bring it up as sum, parentheses, and it's going to be your list, then the minimum, then the maximum value. And then you'll be able to hit enter, and it should come out to be what you're looking for. So in this case, the probabilities that we're looking for is under L2, so I'm going to hit L2, comma. Okay, comma is above here in this above the 7, so it's highlighted in red for me. And at least 5. So one thing you need to keep in mind is that this is looking at rows. So this is actually row 1, row 2, row 3, row 4, row 5, row 6. Okay, so the x value so 5 actually corresponds with row 6. Okay, so I'm going to actually click on 6. And then on the top, I'm going to actually go all the way up to, so this is above more than 5. So my highest x value, and the most successes that we can have, is 8. So that's on row 9, close parentheses. And so when you hit enter, you get a probability of around 85.7%. Okay, so you've got a 85.7% chance that that you'll have at least 5 successes. Okay. The next one we're going to look at is part C. So it says the probability of the number of successes being less than 4. Okay, so notice that this does not include 4. Okay, so we're going to do the same thing. So I'm going to hit second, stat, go over to math, down to sum, and I'm going to again use my list 2 to add we're adding up list 2. Okay, so this is less than 4, so we could have 0 successes, which is on row 1, all the way up to 3 successes, which is actually on row 4. Close parentheses. And so the probability of having less than 4 successes is actually just around 4% chance. Okay, which makes sense because the probability of success, if you look over here, is fairly high. Okay. Now, one other one that we can actually do is find the probability of maybe we're looking for something between, so let's say 3 less than or equal to x less than or equal to 7. So let's say that this is the probability we're looking for. Pretend like these are or equal to's. Okay. So the way we can do this is simply by going second, stat, over to math, down to sum. Again, the setup is the exact same, but now our minimum value is actually going to be, our x value is 3, which means that our row is on 4, and their maximum is actually 7, so our row is 8. And I'm going to hit enter there. And there's a probability of being between 3 and 7 inclusively. All right, so enough of that one. Let's go ahead and move on to Poisson. So first thing is you need to know where Poisson is. So you could use the formula. However, there is a button in the calculator. So if you go to second vars and scroll down, just like if we were finding the binomial PDF, you'll see the Poisson PDF. And when I hit enter, you should see mu and an x value. Okay, so my mu is going to be 5, and if we calculated the first one, so probability of exactly 4, we'd put 4, enter, enter, and it's about 17.5% chance that that there will be 4 of whatever they're talking about there. Okay, so that one's fairly easy. Now, what if they're asking for something a little bit more complicated? So it says find the probability that the number of whatever we're looking for is less than 5. So notice here that we're not actually given a limit, so we don't have a maximum number of participants. We're just kind of given the average. So the way we're going to do this is we're going to go to Stat, Edit, clear all of these other lists that we have. Okay. So for the Poisson, if my probability is less than 5, it could be either 0, 1, 2, 3, or 4. Okay, so this is these are the possible x values, less than 5, so we're going to exit out of that. Then we're going to go into Poisson. Okay, our average is still 5. Our x value now is going to be in list 1. We're going to paste, and we're going to store that in list 2. Okay, so again, to access this, you can take a look. And again, you're more than welcome to just add these up by hand. But we can actually do the same trick that we did earlier, which is second stat over to math, down to sum, and we're adding up list 2. The minimum value is 0, which is on row 1. The maximum value is 4, which is on row 5. Oops, which is on row 5. Enter. And so the probability of being less than 5 is about 44% chance. Okay, and now let's do one more. So here we're looking for the probability that x is greater than or equal to 3. This is the one where you're actually going to have to use the complement. So remember, the complement of greater than or equal to 3 is actually 1 minus the probability of x being less than 3. Okay, so we're actually going to find this here, and then we're going to subtract it from 1. So again, going into stat edit, we're going to create this list. And just based off of the average, this probability is probably going to be pretty high. So let's see, less than 3 would be 0, 1, and 2. Okay, same thing. We're going to go to second, vars down to Poisson. All this information is the same. We are going to store it in list 2. And again, you can go back and you can take a look at these, but we are simply going to go to second stat, math, sum, L1, or sorry, L2, comma, 0 is on row 1, 2 is on row 3, and enter. Okay, so the complement is about 12.5%. So to find the actual value, we just need to subtract that from 1. So I'm going to say 1 minus second negative. So that subtracts the answer. And so the probability is about 87.5%. Okay, so I'm going to leave the geometric example to you guys. However, you can access the geometric distributions the same way. It's right here. You're simply going to type in the probability of success, x value, and so on. Remember, geometric distributions are the exact same as the binomial distributions. The only difference is that here we're talking about the first success, where here we're talking about a certain number of successes. So we'll only ever have one success on the geometric. We're looking at multiple successes here.